So bioamplifiers is the next topic. So what is an amplifier? Amplifier. What is amplifier? Amplifier is nothing but it's going to boost up the weak signal. Okay. Into strong signal. So the bio signal which is taken from your body, any part of the body, will be very low in amplitude. Okay. That low amplitude signal is nothing but weak signal. So weak signal can be boosted up by the device that to be amplifier, bioamplifier, which will make the low signal, that is weak signal, into strong signal. So strong signal is nothing but it will improve the amplitude value of the bio signal. Okay. So this is the usage of bioamplifier in the medical field. So generally, biological signal have low amplitude and low frequency. Okay. Therefore, to increase the amplitude level of the biosignal, an amplifier is designed. So the output from this amplifier are used for further analysis. So for measuring that ECG, EMG, etc. Okay, EOG, everything, you need bio signal from the part of the human body. So that signal will be very small. To amplify that, you are going to use the bio amplifier or further medical analysis. Okay. So basic requirements of bio amplifiers are it should be a high input impedance amplifier. Okay, input impedance must be very high. That is 2 mega ohm to 10 mega ohm. Okay, so higher impedance. Why we need a higher input impedance means it will reduce the distortion of the signal. So the noise interruption to the original signal will be very minimum. That's why we go for high input impedance. Then every bioamplifier should consist of isolation and protection circuit. So why we need isolation and protection circuit from the patient means the patient should not have the electrical contact. Okay, that's why you need isolation and protection circuit between the patient as well as your device, measuring device. This measuring device is nothing but electrode. Okay. So throughout the entire bandwidth range, a constant gain should be maintained. So you are measuring the biosignal from the human body to the equipment, to the electrode. Okay. The electrode only going to convert the biosignal into electrical signal. At that time, the transmission of the signal from human body to equipment, the transmission should maintain the constant bandwidth as well as gain. Okay. And then a bioamplifier should have a small output impedance. But input impedance higher than the distortion together, but output impedance must be very, very low. Okay. And then a good bioamplifier should be free from drift and noise. So bioamplifier it must be free from drift and drifting. It will not be affected by any noise. Okay. Then only you can say that bioamplifier as a good amplifier, good bioamplifier. Okay. Effective and efficient, it will be said to be a good bioamplifier. And then common mode rejection ratio. I think you all know the CMRR value, which is going to be used in the differential amplifier. Okay. So here the amplifier type will be differential type. That's why here we are using the word common mode rejection ratio. Okay. So that ratio should be very greater than 80 decibel. Okay. 80 decibel you can able to reduce the interference. This occurred from the common mode signal. So types of bioamplifiers are differential amplifier, operational amplifier, instrumentation amplifier, chopper amplifier, isolation amplifier. Okay, these are the types of amplifier. So first we are going to see the differential amplifier. So op-amp, operational amplifier, operating in differential mode, can act as a differential amplifier. Operational amplifier பார்த்திருக்கீங்களா? So this is the operational amplifier op-amp. So here you are going to use the both combination of inverting and non-inverting amplifier. Okay. So what is inverting and non-inverting? Inverting amplifier now the output will be opposite to your input. That is inverting amplifier. Non-inverting amplifier now the output will be similar to your input. Okay. So the output of differential amplifier will be like this, V1 minus V2, because here you are going to give two input signal, V1 and V2. Okay, will be given as your input. So the difference of these two signals will be the output. Okay, V1 minus V2 into AD. So AD is ratio, that is gain ratio. Okay, gain. Or factor, multiplying factor. Madri or other than a we will be called it as a gain. Okay, but basically the difference of two input voltage only, output will be output of differential amplifier. That's why the name differential amplifier. The difference of two input. Okay. So the same thing. This circuit is just a combination of inverting and non-inverting amplifier. V1 and V2 represent the voltages applied at its inverting and non-inverting input terminal. AD is nothing but differential gain. So as per this equation, the output of the op-amp must be 0 when the voltage applied at its terminal are equal to each other. There is nothing but if you are applying same voltage to the two terminals of this amplifier, means you will get the output as 0. So V1 no 5 volt na, V2 5 volt na 5 minus 5 0. Okay. Other than the point, the output of the op-amp must be 0 when the voltage is applied at its terminal are equal to each other. Okay. So, in differential amplifier, the input, the two terminal input must be different value. Okay. So, hence, its output voltage will be equal to the sum of the output voltage produced by the op-amp circuit operating as an inverting amplifier and the op-amp circuit operating as a non-inverting amplifier. So both the combination of inverting amplifier and non-inverting amplifier, we have to use it as a single inverting amplifier or single non-inverting amplifier. So op-amp we non-inverting amplifier or inverting amplifier use that's then only will produce the output. In case of combining both inverting and non-inverting amplifier, you will get the output as a 0. Okay. So the inverting amplifier output or inverting or non-inverting amplifier output will be looking like this. V0 equal to minus RF by R1 into V1 plus V2 into RF by R2 plus R3 into 1 plus RF by R1. I think you all learned about the differential amplifier, operational amplifier in the LIC, linear integrated circuit for the people. So, this is inverting and non-inverting amplifier output. So, you are going to consider R1 as R2 and R3 as RF. So, R3 as RF na replace panna enna ho? So here you are going to replace the R3 as RF. Okay. So you will be getting V2 into RF by R2 வந்து R1 convert பண்ண போறீங்க. Get the same value in the equation. Okay. So R2 R1 ஆவும் R3 RF ஆவும் மாத்துறீங்க. மாத்துனா என்ன ஆகும்? Here you will be having R1 plus RF. In the bracket, inside the bracket, we can take the cross multiplication. Okay. Everything R1 plus RF divided by R1. Okay. So in the R1 plus RF, here in the denominator also you will be having R1 plus RF. These two value will be cancelled. Okay. Finally, you will be having RF by R1 into V2. RF by R1 into V2 in the second part. Okay. And then here RF by R1 are same in the two part also. So you are going to bring the RF by R1 common and then minus value at outside, so that you will be getting inside the bracket as V1 minus V2. This is nothing but difference of two input signal going to be the output of your differential amplifier. The next amplifier is op-amp amplifier. So operational amplifier is basically a multi-stage amplifier, okay, in which a number of amplifier states are interconnected to each other in a very complicated manner. We are going to use the op-amp type of bioamplifier in multi-stage. Okay, we are going to use more number of amplifier in the series manner. Okay, so one by one we are going to connect it to get the high amplitude signal. Okay, its internal circuit consists of many transistor, FET and resistor, because we are having multi-stage of amplifier. So it will be having more transistor, FET also a type of transistor and resistor. So it is packed in a small package and is available in a form of integrated circuit. Okay, so the IC level A, you can able to get the op-amp bioamplifier. So multi-stage of amplifier, it will not be looking very large size. Okay, very compact size. So IC size liye you can able to have the whole number of amplifier. It is multi-stage of amplifier. Okay, the term op-amp used to denote an amplifier which can be configured to perform various operations like amplification, subtraction, differentiation, addition, integration, etc. So op-amp LIC la padichirundha, you know this thing. Op-amp application pathinaவே you will be learned. Adder, subtractor, differentiator, integrator nu padichirpinga. Okay, same thing. So that's why the name of this bioamplifier as a op-amp bioamplifier, because of including this all these types of operations. It can be able to do the amplification, subtract, add, differentiate, integrate. Okay, single IC can be able to do all the performance. Okay, so this is the op-amp bioamplifier. It will be looking like your simple op-amp. Okay, but you will be using more number of stages in a single IC. So normally op-amp will have two input terminals and one output terminal. Two input, one output. This at all power supply. You see, the op-amp also has two voltage supply terminal as in figure, and then two input terminals on the differential input. Okay, we call the terminal marked with negative sign as inverting terminal and terminal marked with positive symbol as a non-inverting terminal of the operational amplifier. So this will be, so positive sign irukadanaala this will be called as inverting, non-inverting terminal. This one the minus sign irukadanaala inverting terminal. So if we apply an input signal at the inverting terminal, then negative, that is inverting terminal negative, then the amplified output signal will be 180 degree out of phase with the applied input signal. Okay. So in the input input negative terminal input because this is inverting terminal. So you will get the output as a 180 degree out of phase. Okay, with your input signal. Okay, that means positive signal kuduthina negative kedaikum, negative signal kuduthina positive kedaikum. Okay, and then If you apply input signal to the non-inverting terminal, then the output signal obtained will be in phase. In phase means it will not have phase, okay, zero phase, okay, with respect to your input signal. So input signal positive கொடுத்தா output positive ஆ தான் இருக்கும். Negative கொடுத்தீங்கன்னா negative ஆ கிடைக்கும். In the non-inverting terminal is positive terminal, non-inverting terminal. Okay. This is the ideal op-amp characteristics. So op-amp characteristics is nothing but the voltage gain must be maximum, okay, infinite. Adhe mari input resistance should be infinite to avoid the noise. Zero output resistance irukano, because that means then only you will not have any change in the output. Okay. Then bandwidth should be very infinite. மேக்ஸிமமா இருக்கணும். இதெல்லாம் இப்ப சொன்னது எல்லாம் மேக்ஸிமமா இருக்கணும். அவுட்புட் ரெசிஸ்டன்ஸ் மட்டும்தான் மினிமமா இருக்கணும். அண்ட் தென் நாய்ஸ் வில் பி வெரி ஜீரோவா இருக்கும், மினிமமா இருக்கணும். பவர் சப்ளை ரிஜெக்ஷன் ரேஷியோ ஆல்சோ மினிமம். அண்ட் தென் காமன் மோட் ரிஜெக்ஷன் ரேஷியோ CMR must be very high. Okay, these are the characteristics of ideal op-amp. The next type, instrumentation amplifier. சாரி, ஒரு 2 minutes மட்டும்தான். இந்த டைப் மட்டும் முடிச்சோம்னா நமக்கு இந்த டாபிக் ஓவர் ஆயிடும். ஓகே, so be silent. Instrumentation amplifier. So in biomedical application, high gain and high input impedance are attained with an instrumentation amplifier. Why we go for instrumentation amplifier means to achieve the high gain as well as high input impedance. So high gain and high input impedance irundaduna, you can able to avoid the distortion in the output, as well as you will have the effective and efficient output the output terminal. Okay, that's why we go for instrumentation amplifier. So usually instrumentation amplifier will have 3 amplifiers set up. Okay, so first 2 amplifier will be non-inverting amplifier, and then third amplifier will be differential amplifier. Okay, so 2 in non-inverting amplifier and 1 will be differential amplifier. So totally 3 amplifiers will be used in the instrumentation amplifier setup. Okay, so the output from the transducer is given as input to the instrumentation amplifier. This transducer will get the input from the human body biosignal. So transducer will convert the biosignal into electrical signal. That electrical signal will be very low amplitude in nature. Okay, to make them boost up or to make them strong signal, we are going to use a amplifier. So here we are going to use the instrumentation amplifier. Okay, next stage of transducer. Okay, so before the signal goes to the next stage, a special amplifier is required with the high CMR, high input impedance, and to avoid loading effect. Such a special amplifier is said to be instrumentation, which do all the required processes. So this is the instrumentation amplifier. Here you will be having 3 amplifiers. First two will be inverting and non-inverting amplifier, and third will be your differential amplifier. Okay. So இது பாத்தீங்கன்னா inverting amplifier, this will be non-inverting amplifier, this one is differential amplifier. So to each input of the differential amplifier, the non-inverting amplifier is connected. So from the figure, the amplifier on the left side will be acting as a non-inverting amplifier. They are combined together to form the input stage of the instrumentation amplifier. So in the two amplifier தான் inverting and non-inverting amplifiers. Okay, left side of the instrumentation amplifier. That means entering port of instrumentation amplifier or input side of the instrumentation amplifier. So at the output side only, we will be using differential amplifier. So the third op-amp is the difference amplifier, and it is the output of the instrumentation amplifier. The output from the difference amplifier will be V out, which is the difference between 2 input signal given at the inputs of inverting and non-inverting terminal V1 and V2. Okay, so this will be these 2 signals. The difference will be the output of difference amplifier. So V out equal to V1 minus V2. See, look at here. We'll be getting the output as V1 minus V2. So V out 1 minus V out 2 is nothing but output of first amplifier, output of second amplifier. That will be given as the input to the third amplifier, is difference amplifier. So V01, V02 will be the input of this amplifier. So the input of these two amplifier only, the output of these two amplifier only input of third amplifier. So input of this amplifier will be the output of third amplifier V out. Upper V out equal to V01 minus V02 into resistance value R3 by R2, feedback resistance by actual resistance. Okay. So next we are going to see the isolation amplifier. Okay. Isolation amplifiers are known as pre-amplifier isolation circuit. So which will be used as a pre-amplifier. Pre-amplifier na amplifier previous stage. Okay. It will be called as a pre-amplifier isolation circuit. So this isolation amplifier will increase the input impedance of a patient monitoring system. It will help to isolate the patient from the device. So using this amplifier, we can prevent the accidental internal cardiac shock. Due to the electrical signal generating at the device, it will be able to have a internal cardiac shock. So that can be avoided by providing the insulation, that is 1012 ohm between the patient and power line, that is power line from the device. Okay. In the hospital, you can avoid all the accidental cardiac arrest. Okay. And this is the structure of isolation amplifier. Here you will be having the amplifier, modulator, LED or primary winding of transformer, and then this is the isolation. Here you will not have contact with the device. Okay, the arrow mark irukadu. Isolation barrier mattum da irukum. Inda arrow mark eduthunga. So next part will be output parts pathina, photodiode or secondary winding of transformer, demodulator, amplifier, and then output. Okay. This input is nothing but your biosignal from the human body. Okay, this will be given to the amplifier, which will amplify the weak signal into strong signal, and then given to modulator, which will modulate the signal, normal signal, electrical signal, and then the transformer, primary winding and secondary winding is the concept of mutual inductance. So mutual inductance is nothing but the voltage which is present in the primary winding will able to produce the EMF, electromagnetic effect, in the secondary field. Okay, without having any contact. Okay, adhe mari LED pathina, which will be converting the electrical energy into light energy. The photodiode, which is used in the second part, will absorb that light energy, okay, which is emitted by the LED. Okay, that will be absorbed by the photodiode and converted into electrical energy in the output side. Okay, this signal will be again demodulated. Inge modulate pannade, similarly it will be demodulated. Evlo modulate pandriya adukku etapla it will be demodulated, and then again amplifier will be used, and then it will be given as a output. Okay, so isolation amplifier main theme is to isolate the patient from the electrical signal. That's all. To avoid the electrical accident. So block diagram தான் இங்க explain பண்ணிருப்பாங்க. That's all. அவ்வளவுதான். Isolation amplifier over.